Hey everyone, I'm Wojtek, and I work at Dashbeat. We help grow the open source Elixir ecosystem, and we work with companies to help them adopt and run Elixir in production. And today I'm going to talk about library client-server Symmetry, which is kind of vague, but hopefully will make soon sense. So let's take a look at some data formats. So here is base 16, and we have in the Elixir standard library functions to encode and decode that. Pretty simple. We have the string hello. We can encode it, and then decode it. I would say that the Elixir pipe operator makes it really like emphasizes the idea. We encode, decode, get the thing that we started with. Another example is ISO 8601, which is a common format for representing date times. And again, we can encode it and decode it. Again, we have JSON. We can encode and decode. You can see a pattern here. Here's another example. It is not in the standard library. This is a package MDEX. Shout out to Leandro who created it. We have a string of Markdown, and we can parse it. And we are going to get something like this, which is kind of like AST. It's a semantic representation of the Markdown. Yeah, we can parse this and then turn it back into text. So again, we have this encoding and decoding. We have a bunch of formats in the Elixir and Erlang standard libraries. I may have missed some. And then we have way more on Hex. And I wanted to show you one more example, which is not, which is a bit different. So this is a Nibble TOTP, TOTP as in time-based one-time password. So this is, you have a two-factor authentication, and that's 6-digit code. This library allows you to manage that. And in this library, we can generate the shared secret, shared as in between quote-unquote client and server. The authenticator app would use this secret to generate the code, and then let's say on the backend you validate if the code is correct. And most users, unless you happen to work on this authenticator, would only use the validation logic. Right? Someone comes into your website, enters the 6-digit code, and you check if it's true, valid or not. But I wanted to show you this example as that, like, even though you are not really gonna use the verification logic in production, I think it is very nice that it is there, and that this library, even though it's different, right? Like it doesn't encode or decode stuff like shown before, I would still consider that that it is a complete library for this problem. It has that, so to speak, client and server symmetry. So now let's turn to HTTP, probably one of, if not the most important protocol for exchanging information. And here is a simple example. We have HTTP request on left and response on right. And we are sending some data. The client sends a string hello to the server, and then the server is just an echo server. It is going to return it back to the client. And let's make some modifications to it. So instead of sending plain text, let's start sending JSON. So we encode the body, and let's say let's start compressing the body as well. So now we have the different content length, and we have this encoded body. And instead of having the content length known ahead of time, we can do streaming. So by the way, this is just going to be HTTP1, which has different streaming than HTTP 2 and 3. HTTP 2 and 3 are much more complicated, but the general idea, the semantics are pretty similar. So I think this is still hopefully a useful example. In any case, we can start streaming or sending chunks. So the way it works is first you give it a number, how many bytes are you're going to send next, then you send them, and then you send another length, and then a 0 at the end. Throughout this example, you can see that the request and response are exactly the same. We use the same ways to encode data and sort of like encode the data, but also represent what we are doing in the headers. And for completeness, when we compress stuff, the client tends to set that accept encoding header, which is like, hey server, by the way, I support gzip, so if you are gonna compress with it, I'm gonna be able to decompress it. So this is also called content negotiation that the clients and servers can do. So in any case, we have this pretty symmetrical protocol, right? Like the request and response are exactly the same. And then we have, let's take a look how we can interact with the protocol in Elixir. And on the left side, I chose rec HTTP client, which I wrote. And we create a request, and we make the request, we get the response back, and we are just going to print some response body and headers. And then on the right side, we have HTTP server. Here it's bandit, and it uses the plug API. And here, again, we are going to have this echo server. So we read request body, and then we print it, and we print the request headers, and then we send the response back to the client. So yeah, so this is like a HTTP client, HTTP server. The protocol is quite symmetrical, but these APIs are not quite symmetrical. So I want to sort of go a little bit over these differences throughout the talk. What we're going to have with rec, we're going to have the response body as hello, and then we have headers. I chose to represent them as maps. And then on the server side, we have the request body, but it is not part of that con that you are very familiar with when using plug. We had to read manually the request body, and then we have headers. So it is quite different. Let's take that server example and go through plug API, then or like kind of how plug works, and then we are going to briefly talk how rec kind of works. Same code. I'm just going to move it around a little bit. Instead of having a function plug, we can have a module. And then this module uses the plug builder, which allows you to kind of like put a bunch of plugs in order, and then plug is going to execute them. But yeah, this is this is the same code. And now let's start to make some modifications. We have that echo server, but now we are talking JSON. So we are going to decode JSON, and then for sending response, we are going to encode to JSON. Again, this is pretty silly, right? Like we are decoding and encoding the same thing, but hopefully it shows the idea. After we encode, we set the content type header, and we send the response. This part about reading JSON or some other formats is abstracted away by plug. You can do it yourself, but there is also a plug called plug parsers that can do it for you. And so we can remove that code. And notice I mentioned that we don't have con body, like the raw request body, but we have with plug API, we have this con body params. So plug parsers puts data into this body params field on the struct. Here we use the JSON parsing, but there are two other popular kind of by the specification formats available as well: URL encoding and multipart. And you can bring your own parser as well with plug. And in terms of sending back the response, again, we can do it manually. But there is also in Phoenix a little helper which does that. Phoenix is not part of plug, of course, but it's built on top of plug. And as an aside, if you ask me, I think this little function should be definitely in plug, but that's neither here nor there. We have that echo server that speaks JSON, let's say, and then we can invoke it with bandit like this. We just pass this module as the plug, So I showed the so in the raw HTTP details we saw JSON encoding, we saw compression, and then streaming with chunks. With Bandit, we don't handle compression. I mean, we can handle compression ourselves, but it has a feature built in, but it's not through Plug API. It's kind of like an option on Bandit, which is interesting. And then that streaming, these streaming chunks, that's not even an option. That's just something that is there, which I think is it's totally fine. Just kind of interesting. Which parts of these protocols are implemented by default, which parts are opt-in, and which parts you have to do yourself. And so let's briefly go over Rec. So this code is basically equivalent to the following. We start with Rec, we build up the request struct. So we keep request headers and body and options for later. And then Rec basically runs through steps, which are kind of like these plugs. So there is an encode body step, which is not going to do anything here. Like the body is a string, it's just going to leave it as is. However, if we change the body, instead of sending the body option, we send the JSON option, now the encode body step is going to encode it. So it's going to set the headers and encode the body. And same thing with compressing the body. By default, it doesn't do anything. However, if we set the compress body option to true, now it is going to compress it. And then at the end, we use a library called Finch, which makes the actual network request. Finch is pretty fascinating, but I'm not gonna be able to go into details. But basically after that, we get the following: a tuple of two elements, the request that we had along the way, and then a response. So this is that JSON echo server. It's gzipped, and we have a bunch of bytes, and then we can start decompressing body. And I think it's kind of interesting that, like, on the client end, we were opting into, using JSON or using gzip or compressing and stuff. On the server end, we can do it automatically because we know based on the HTTP headers. So the HTTP header was that, oh, there is a content encoding gzip, so this is just going to decompress it based on that header. And then there is a content type JSON, so this decode body step will automatically decompress that. So this was just a short overview of Rec and Bandit. In Rec, we have two structs. We have request and response. In Plug, we have one. I would say that having two different requests is maybe more popular. I did mention that I use Finch, so Finch has two structs, so I kind of started with those. But I would say that this is actually what most people expect most of the time. Like, most of the time, you just make a request, you get a response, and this is it. Like, you don't care what was the request that you sent. Like, with Plug, there was maybe more focus on that kind of middleware approach, passing everything around. In Rec, we have request compression and response decompression. In Plug, we have response compression, so that's internal. That was that compress option. For Bandit, there is a module for that, but it's private. And then in Rec, we have request JSON encoding and response JSON decoding. In Plug, we have that Plug parsers plug, which decodes a request. We don't really have like encoding JSON in Plug. Again, I would throw in that little JSON function in there if it would be up to me. But finally, so I'm not going to go into details, but very briefly about streaming. In Rec, we can set the body option to enumerable. So that's anything that implements the enumerable protocol. This is how we stream data in Rec. And then for handling response streaming, we use the collectible protocols. There is an into option, and you can collect into kind of anything. There is a protocol, you can implement it for different data structures. So that's a way to extend sort of rec with your own things without changing rec. In Bandit, we have a much more straightforward API for streaming incoming request body. We use the read body. For streaming outgoing response body, we use chunk. We have quite different, even though the protocol is symmetrical, we have quite different clients and servers. They actually share very little code, like all of that compression and encoding and decoding. That's actually not shared at all. But the protocol just, I think, just like screams, right? To at least to me, to kind of reuse all of that. And I would say that especially for performance stuff, like there are very subtle things that you can do performance-wise to, like, you know, tune exact buffer sizes and things like that. And it's actually very similar between requests and responses. So I think we kind of leave a lot on the table. Yeah, like, let's see how we could maybe design an API that would have that symmetry. So let's say we start with some struct that is going to hold our data for request, and then we kind of pass it through things. So we encode and compress it and encode into chunks, and then maybe we send it over the network socket. So this will be sending the encoded HTTP protocol payload. And then on the other end, we would receive, so that would get all of those bytes and maybe turn this into this data structure, and then we would start decoding the chunks, decompressing it, decoding the body, and same for response, right? We start with the data structure and we encode, compress, chunk, send, and then back to the client, we get data, we get that response, and we decode. So some similarities, like this, you know, encoding request and encoding response. Again, this is exactly the same, right? And same for decoding. This is exactly the same. So I think maybe there is something to it. A good friend of mine, Jason, said that it is a very nice pipe dream. And the thing about that is that, yeah, it's a dream because it doesn't actually work that well. Because, yeah, like, okay, how do we choose these exact data structures? There are some performance considerations around that. Maybe you want to hold data and transform it, or maybe you don't. Maybe you would rather send messages instead of passing this data around. So it is kind of tricky, I think. But the biggest problem with this is streaming, which is that, you know, this code, this doesn't actually work, right? Because, like, it's not like we would receive some data and then we would get chunks. We get chunks as we receive the data and then ask for more. And same with decompressing, like when we stream. So we got some data from the socket, we got the chunk, and then we try to decompress as much as we got from that chunk. And then maybe with something like JSON decoding, we maybe try to decode as much as we can from that chunk, and kind of like as the data comes in, we try to efficiently decode it. So pipe doesn't really work here. It could kind of work if you use Elixir streams. You could, you know, kind of like pipe these operations. There are some performance considerations with streams. But even though pipe doesn't work, I would argue that, like, the idea to have these functions is maybe there is something to it, because again we have this unquestionable, in my opinion, symmetry. So we are not going to have a pipe, but I think having a bunch of these functions that implement the protocol, maybe there is something to it. Okay, so we saw the high-level usage with Rec and with Bandit. They don't really share any code, as I mentioned, like none of the encoding and decoding, but they do share something, which is they share the Erlang standard library. Specifically, they share the Erlang network stack, which they use to communicate. So let's actually, instead of starting from the high level, let's start from the lowest level, reasonably lowest level, which is using GenTCP. So we start with options. These are common GenTCP options. Binary means we get data as binary as opposed to lists of numbers, list of characters. Active false means that we are going to use the network socket in the passive mode, meaning that we are going to manually read from the socket. This is as opposed to the active mode, which is the calling process would get the incoming socket data as Erlang message. So for simplicity, we just use the passive mode. And so on the server end, we listen on a network port, on port 4000, and then let's say in a separate process, again, caveats, this is very simplistic. There is no error handling, there is no performance considerations, but I think it is kind of true to the idea how you would actually go about building it. So we listen on the socket and then we accept a connection, meaning we wait for a client. So this accept is going to block until on the other end of the socket there is a client. So on the other end we connect to that socket. So now this accept would unblock. So the client would send the request, the HTTP protocol payload, and then the server would receive it. Again, that would be a blocking call. And then the server sends back the response, and then the client waits for the response. Of course, this is, again, simplistic. You would want to stream it, so continuously getting the data as it comes in. But this, I think, hopefully gives you an idea that how it kind of works on the lower level. And what is kind of cool about Erlang, I would say, is that like this, I was kind of not sure how to best represent this, but like if you squint, you could almost put all of this in a single file and it would just work, just because we spawned that extra process for server, which is kind of cool. Like there is no magic, it's just using the network stack, and it's pretty easy to use. In any case, we used GenTCP for client and for server, and I would call that definitely symmetrical API. We have a single abstraction that we can use to send and receive data, so that project has been around for quite some time. It's called Mint, which is a low-level HTTP client written in Elixir. And the idea, yeah, we do have a bunch of Elixir clients, right? I'm definitely not part of the solution and part of the problem. But Mint is very interesting in that it is basically at that level of the network socket. It just adds a little bit of the HTTP protocol, but otherwise it is it is low level. It is almost exactly at that level of GenTCP, which I think is fantastic. It's not like super easy to use. Like if you want to just get some data like really quickly, it's not like super ergonomic, but it is an excellent foundation for sure. And when Mint was just getting started, there were some ideas about having something like that in the Elixir standard library. That did not happen for some reasons, and then Mint became its own project. But throughout that time, there was this idea that maybe we actually do have some kind of generic network socket. And what I would argue then is that, so it was pretty clear for the client, but like, yeah, why don't we do that network socket for the server part as well? Why don't we have a single abstraction that can do these HTTP, low-level HTTP stuff very efficiently on both ends, and then we can build something more ergonomic and share ergonomic on top, but otherwise share all of these important details. And if it would be up to me, I would definitely make it part of the standard library. I would even make it part of OTP, because why not? But no, truly, right? Like there is a bunch of projects in Elixir and Erlang. I think they might be missing this abstraction. Not saying it's exactly this, but maybe something like this. And going back to that wishful thinking API, let's say we switch it to GenHTTP and kind of go over it really quickly. I think compressing and encoding chunks, definitely sending over the network, to me, that's definitely part of this low-level network socket abstraction. Encoding body, though, I don't think so, right? So I think something like maybe rec, choosing which representation you want to send and having some conveniences, to me, that makes sense. And then on the server end, I think getting the data from the socket in a streaming fashion and then decompressing, to me, definitely makes sense. Decoding body, probably not, to be honest. I think this plug parsers abstraction is very nice for that. And then same idea. Again, we have that symmetry. I think something like Phoenix controller JSON, or if it's part of plug, a separate thing. But otherwise, all of the encoding stuff I think fit in this GenHTTP idea. And then same on the receiving end from the client, receiving the response. I think something like rec could help with doing some, like decoding like JSON, or having that point of extensibility to make it more useful. And I would say that to me, these are maybe capabilities that fit together pretty well. I believe there is a lot of code reuse between them. And as far as these other ones, right now, they are some of the stuff is in rec, some of the stuff is in plug. Maybe it would make sense to make it part uniform. Maybe it doesn't. It's kind of a different story, kind of one step at a time. But like the idea is, okay, maybe we have rec, maybe we have bandit, but they share now a bunch of code, those low-level important performance details. But we have some stuff on top, so we have some other options in the community. Maybe they will be using that as well. And on the Erlang side, so to speak, we have Gun, Cowboy, and Cowlib, which they are all written by the same person, Loic, and like he knows it, right? Like he shared that code in the Cowlib and implemented the client and server on top, so he gets it, right? And maybe, so I don't know, maybe there is some opportunities to share code as well. And so to conclude, if you can create symmetrical libraries, that's just easy. However, if there is no symmetry, so like, okay, let's say for some reason I write a new HTTP client, right? That's not easy. So it is kind of hard ask to, okay, so why don't you write a client and a server as well? So kind of pick your battles. And maybe there are some different considerations for one or the other. Maybe there is not the symmetry, there is no obvious symmetry. So I think what we can do is try to drop down a level of abstraction and try to find symmetry there. And that's it. Thank you.
Yeah. To say that I really like, I use rec and I really like it.
Thank you.
If it also will support web sockets, would be nice.
Sounds good. No, I have some ideas, but it's we can. I'm happy to talk about that after this.
Since we started with wishes, does Bandit have quick?
Nope.
Yeah, because actually you talked about Gen TCP, but HTTP3 is UDP, not TCP.
It doesn't have support for quick, but I'm pretty sure that PRs are welcome.
Yeah, would love to do it, but it's not easy.
We have to pick our battles. As you say.
Yeah, right. It is not easy. Yeah.
One, just a remark, right? For streaming JSON, you're obviously in trouble like since the beginning, right? Because to parse JSON, it needs to be like complete. So you need some other form, like some like parallelized JSON or whatever, right? But that's just a remark. What I wanted to say, and like really sorry for bringing the discussion down to this level, but in the JavaScript world, there's like a bit of analogy happening. There's like when the fetch happened, right? Like the standard for fetching in web browsers, and then it was moved to the server world, right? So you were writing endpoints in Node format, and now like people are switching to this approach like Hono.js or stuff like this, where the interface is like the same as the fetch. So your structures for requests and responses are the same. So there's like a bit of maybe what you're trying to do here.
Yep. No, seriously, I'm quite fond of that symmetry. Like especially with something like Dino or Ban, they have that top-level serve function which accepts a request and returns the response. So there is definitely some symmetry there. I mean, was there a question, by the way? No.
Just like
I think
your thing was a bit of a question, right? So
yeah.
trying, maybe not an answer, but like
No, definitely. So that's kind of what I maybe alluded to a little bit at one of the later slides. That like, what do we do about these, right? Like, do we maybe try to have a single uniform abstraction for the client and the server, maybe? So yeah, I think a little bit about that. I don't really have any answers. What I would say though about like requests. So on one hand, it kind of got, I don't know if it's like a right framing, but like, should we have just a single plug con thing, right? Or do we have different structs? There are trade-offs between these two approaches. Maybe they are not worth it to diverge. So maybe, I don't know. I think picking our battles, I think there is, I wouldn't say maybe low-hanging fruit, but there is definitely opportunities to improve the situation like on the lower level. I think we would, I really think so that we would benefit from more sharing, and then I think we can maybe change stuff on the higher level as well. Yeah.
So is your new framework gonna be named Res? This will be on the
Right.
server side.
I'm definitely not doing that. Yeah. All right. I think this is about it. Thank you so much.